Hello and welcome to a new video. This is for Math UC Zeta. We are on lesson 18, which talks about dividing a whole number by a decimal. So in lesson 17, we introduced the idea of taking a decimal and dividing it by a whole number. So we said, okay, if you've got something like $1.25, you can divide 5 into that, and what happens is you just move the decimal up above, and as long as you're keeping track of places like you're supposed to, it works out that the decimal just goes, like the decimal just goes right up above. So it's great. But we have actually two other situations, and so this is the middle kind of situation that we've got. Because we could have a whole number that we are dividing by a decimal. And by decimal, I really mean something that's in between 0 and 1. So we can have decimals, right, like $1.25. That would be bigger than 1. But we're thinking of things like 0.1, 0.2, 0.3, 0.4, and so on. So before we actually dive into that, I want us to kind of think about what situation this is representing. Like, when would you actually take a whole number and divide it by a decimal? Where's the context? So let's think about if we have a bag of cookies that we're trying to hand out to our friends. So if we've got 10 cookies and we've got 2 friends, we can divide and figure out, hey, those 2 friends each get 5 cookies. If we've got 10 cookies but we have 5 friends, right, we divide 10 divided by 5 and get 2. They each get 2 cookies. But what if we have 10 cookies but we have so many friends or classmates or whatever you want to call them that we're like, we have more friends than cookies, so let's go ahead and divide each of the cookies in half and then hand them out. And so in that case, if you're saying, hey, I've got how many cookies did I say we had? We had 20 cookies? No, we had 10 cookies. So in that case, if we have 10 cookies and we're saying, let's see how many halves are there in 10, that would be a situation where we're doing 10 divided by a half or 10 divided by 0.5. Think through that. If you divide each cookie in half, how many halves do you have? You would have 20, right? Because the first cookie has 2 parts, the second cookie 2 parts. And so you basically are doing 10 times 2. And if we were doing this with fractions, what we'd actually do is 10 times, and we'd flip the 1/2 over, because that's how we divide by fractions. We'd end up doing 10 times 2. The whole point to this is to help us understand that when we divide a whole number by something that's in between 0 and 1, like we're going to do today, it actually gives us an answer that's bigger than what we start off with. Another thing that we could do is we could think of quarters or dimes or nickels or something to that effect. Because if you have a certain amount of money and you decide you want to change all of those dollars, however many they are, into quarters, let's say you have $50 that you've been saving up because you want to go to the arcade, because that's what the cool kids do these days, right? So $50, you're going to change them all into quarters so that you can go to the arcade and just play games all day long. How many quarters does that give you? $50. There are 4 quarters in a dollar. So you're going to end up with more than 50 quarters, right? Essentially what we would be doing if we wanted to figure that out, though, is 50 divided by how much a quarter is, which is 0.25. And so 50 divided by 0.25 has to give us something bigger than 50. This is just background information. There's anytime we do math, there's kind of 2 things that we need to know about any situation. We might need to know the why of the situation. I guess maybe there's 3. We might want to know 2. Why and how. So we might want to know the why. Why does it work the way it does? And then we might want to know, how does it work? And we don't always need to know both of those things. Most important most of the time is the how, because in order to actually do a problem, you have to know how to do it. But as much as we can know the why as well, like, we actually end up with a deeper understanding, which is really cool. So all that to say, if that's not quite making sense, then as long as you're understanding how to do it, that's okay. So let's look at some examples. Now, because we're dividing by decimals, there's a step that we're going to kind of add to our process that we didn't have last week. So I'm going to set this up as 0.5 I'm dividing into 48. Now, in order for our decimal places to work the way we need them to, 48 has a decimal, even though it didn't have one written. What we need to do actually is make it so that the outside number is not a decimal anymore. So what we're going to do is we're going to move that decimal over to the right one spot. We're moving it to the right because then it'll be 5 instead of 0.5. And when we do that, the 0 no longer is necessary. So honestly, this would be a case where not writing it is actually helpful, because you might get confused if that 0 is there. So we're going to take this 0.5 and we're going to turn it into 5. But we're not just allowed to do things like that in math willy-nilly. So because we did it on the outside, we're also going to do it on the inside. So I'm going to take this 48 and I'm going to move it over. I'm going to move the decimal over one place. So that instead of doing 0.5 into 480, what I'm going to actually do is, instead of 0.5 into 48, I'm actually going to do 5 into 480. Now, here's the why of this. Another way to write this is as a fraction, right? And remember when you did fractions and you had to like get common denominators and things like that, how you talked about if you multiply the bottom by something, you have to also multiply the top by the same thing? We're just in general talking about equivalent fractions, right? You have to do the same thing on top and bottom, otherwise you've changed the number. So what we're doing when we move the decimal over to the right one spot is we're really timesing by 10. That's what moves it from 0.5 to 5. But in order for us to do that to the 0.5, we also have to do that to the 48, which is how we're getting 480. So that's the process we're going through, that we do it every single time, and so we kind of forget that that's why that's happening, or not pay attention to it, because we just get used to, hey, I need to move so that the number outside's not a decimal anymore. I need to move the decimal however many places it takes, but I also have to do that to what's inside. Now it's just regular old long division, like the good old days. Okay, so 5 into 4 doesn't happen. 5 into 48, that goes 9 times. Subtract 5 times 9, which is 45, and we get 3. We're dropping down this 0. 5 into 30 goes 6 times, so that's nice. It worked out really, really nicely, and our answer is 96. We could have maybe come up with that a different way, right? Like my cookie analogy earlier. Let's say we have 48 friends and 48 cookies. Let's say we have 48 cookies and we're saying how many half cookies are there in 48 cookies? Well, each of the cookies has 2 parts. So 48 times 2 would be 96. So just to throw that out there, how this is all kind of coming together and working. Let's look at B. So same kind of situation. We're going to do 0.1 into 122, but our very first step is going to be to say, I don't want to do 0.1. I want to move the decimal over one place to the right, which means I'm going to do that on the 122 as well. And then I personally like to rewrite it. You maybe don't need to rewrite it, but I like to rewrite it because I think it looks kind of messy the way I have it with the little whoop whoops. Now, this is actually a really easy division problem if we realize it, because when we do 1 divided into anything, we get that thing. Like 2 divided by 1 is 2, right? So 1 into 1 is 1. 1 into 2 is 2. 1 into 2 is 2. 1 into 0 is 0. So that worked out nicely, actually. That because we got rid of the decimal place, it was a really, really easy division problem. Let's look at these next 2. Let's see. 138 divided by 0.12. We also could just think about moving the decimal before we write the problem down. So I could think, okay, this actually has 2 places I need to move it, which turns this into 12. So if I move this one 2 places, I'm going to have to add 2 zeros. So that's going to be 13,800 divided by 12. Now, you may already realize this, but the reason that most of us are not such huge fans of long division is because of times when you have to really work hard to figure out how many times something goes in. And that either could be because you aren't solid on your multiplication tables, or it could be because it's a number that's not a part of the multiplication tables. Like 12 actually is, although some of us don't know our 12 super well, and that's, you know, neither here nor there. But if we were dividing by like 35 or something, that's not a part of the multiplication tables. It just makes long division feel kind of annoying as we have to figure out multiples of 35, basically. So I'm just trying to say, like, I get it. I get why sometimes we don't like long division, or maybe most of the time we don't like long division. I feel ya, I sympathize, I empathize, but we're, you know, it is what it is. Okay, let's see. 12 into 1, no, that does not go in. 12 into 13, yes, that goes in. And then we dropped down the 8. 12 into 18 goes once. So I'm going to subtract 12. 12 into 60 goes 5 times. And then 12 goes into 0 0 times. So our answer here is 1,150. I have a habit, you may have noticed, of not always putting the commas where they go. Decimals are super important to put if you need a decimal, but commas not so much. Okay, last one. So, and part of the reason why I didn't do a ton of examples here is in class, I actually focused quite a bit on just doing math facts in general for practice. And so that's certainly helpful for you to spend your time on reviewing multiplication tables, reviewing addition, subtraction, multiplication, and then also reviewing like what we did last week with division. And then you can actually make up problems on your own if you need to, or have a parent or sibling do it. I mean, it may not be super pleasant for any of you to spend your time doing that, but it is something you can do pretty easily. Like you pick two numbers to divide and voila, you've got a problem. It may not work out super nicely, but at least you're still practicing, right? All right, so this time we need to not move the decimal just one place, not just 2 places. We need to move it 3 places because this is 0.003. I'm actually going to mark out this 0 so it doesn't confuse me. I'm going to go 1, 2, 3 so that we're putting 3 into 1, 2, 3. So this is really, really high quality stuff here. Oh, that's not where that goes. 213,000. So 3 into 2 doesn't happen. 3 into 21 goes 7 times, and we subtract 21. We drop down the 3. 3 into 3 happens once. And then now we're just going to keep getting zeros, so all the rest of these end up being zeros. So our answer here is 71,000. Just real quick, let's look back at each of these. Each of our questions, well, hang on. Each of our questions, right, started off with a number divided by something that was between 0 and 1, a decimal number, and each of our answers actually ended up being bigger than what we were dividing into, because essentially we're being asked how many like of these little bitty parts are there in this big number. And so because, for instance, 0.003 was super duper small, there are a lot of 0.003s inside the number 213. So we got a really big answer. So that's just something to try to help you look and be like, oh, I think I maybe got this right because of how big the number is, or maybe I got it wrong because the number is not bigger than it started, or things like that. So thanks so much for watching. Hopefully this helps you out. Please feel free to give me a like and a subscribe, and I'll see you in the next video. Bye.